Lesson number 13, Bombardment. By the end of this lesson, you should be able to describe what is meant by a thermal neutron, and use thermal neutrons in nuclear equations, and describe the bombardment of certain stable elements with proton radiation to make them into radioactive isotopes that usually emit positrons. The radiopharmaceutical used in PET scanning releases positrons. The radiopharmaceutical is a radioactive isotope which can be produced by bombarding a stable element with proton radiation. In order to bombard an element with protons or other charged particles, the protons need to be moving at high speed and energy. This can be done by accelerating them in a type of particle accelerator called a cyclotron. A cyclotron consists of two electromagnets which create a magnetic field in the region between them. Inside this magnetic field are two electrodes called D electrodes, or Ds, because they are D-shaped. The Ds are hollow so that particles can move inside them, and there is a small gap between them. A radioactive source in the center between the Ds releases protons or other charged particles. A voltage is applied to one of the Ds to attract the particles. Once the particles are inside the D, the magnetic field forces the protons to move in a circular path. As the particles leave the first D, the voltage on the second D is changed so that it attracts the particle. A positive particle, for example, will accelerate towards the next D if it is more negative. The particles gain speed while they are in the gap between the electrodes, so the particles move in a spiral, getting faster and faster each time they pass between the Ds, until they leave through the exit tube. In a cyclotron, accelerated protons are used to bombard stable atoms to produce positron-emitting radioisotopes used in PET scanning. Some of the cyclotron-produced radioisotopes used in PET scanning are very short-lived and must be administered to the patient very soon after production. For this reason, cyclotrons are installed next to PET scanners. Another way of producing radioisotopes is in nuclear reactors using thermal neutrons. These are slow, low-energy neutrons which have a kinetic energy similar to that of the surrounding particles of gas. They are free neutrons, not bound in the nucleuses of atoms, and are useful in chain reactions. Stable atoms can be bombarded with thermal neutrons to create a heavier isotope of the atom. This new isotope is neutron-rich, and the excess of neutrons make the nucleus unstable. It is radioactive. Thermal neutrons are used in boron neutron capture therapy, BNCT, where a stable isotope of boron-10 is attached to tumor cells inside the body. The tumor cells are then bombarded with a beam of thermal neutrons. The boron captures the neutron, then undergoes fission to form lithium and an alpha particle. These particles destroy any cells nearby, the cancer cells, but do not penetrate further, so healthy cells are not affected. BCNT should therefore reduce side effects from other cancer treatments such as radiotherapy and chemotherapy, and is particularly useful for brain tumors.